Okay, so let's get started first. Let's try understanding what we are trying to learn today. So today I had sent a message. We are kind of tired of talking about matrices. We have talked about it for quite some time. So that's why for a change I have changed the topic, and today we'll learn about the polar coordinates and polar equations and how do we graph them. Okay, so let's see how much we can cover today, and whatever is remaining that we'll try covering in the next class. So a quick question to you guys. What is your understanding of polar coordinates? And the first question that should come to our mind is, why do we even need to learn that? Any thoughts?
Isn't it like it could be used in radars?
Okay. Okay, that's a very deep answer in your terminology. You guys say this is not deep or this is very deep. So this is a very deep answer. Chris, how about you?
Sorry, I didn't hear. I had to step away for a moment. Could you repeat?
No, I was asking, today we are going to learn about polar coordinates. So I'm just trying to understand, why do we even need to learn about the polar coordinates?
I don't know what a polar coordinate is, so I wouldn't know.
Okay, that's a fair statement. So, when we talk about coordinates, the first thing that comes to our mind is the way to identify a location. Okay, so and that's precisely what we have learned in the previous classes. We talked about the Cartesian coordinates or rectangular coordinates, whatever you call it, where you are measuring or you are locating a point against two axes. One is the x-axis, which is horizontal, and another one is the y-axis, which is vertical. So this is called Cartesian coordinates, where you say, okay, fine, if this point is against x, how far, and against y-axis, how far. And that helps you locate where exactly the point is. If you're talking about this point, then you say, okay, how far on the x-axis and how far on the y-axis. This is our understanding of what is the Cartesian coordinates and other rectangular coordinates, but whatever you call it. And it helps us locate a point. So this is one way of locating a point in a plane. Similarly, if you guys remember, right, when we were learning about the vectors, we learned about the thing that if we are talking about a vector, we are talking about the magnitude, the value of the thing, and the direction in which it is. So polar coordinates is nothing but are the representation of vectors in a plane. So that's why it's called polar coordinate. It's essentially the same thing. If you look at a polar coordinate, how you're talking about a polar coordinate is, let's say if I'm talking about this point, instead of saying x and y, I will locate this point as how far from the origin, let's say I'm calling it a radius, and then what is the angle that it makes it with the x-axis. So if you're talking about this point's polar coordinates, you say, okay, fine, this is the distance from the origin, and this is the angle that it makes with the x-axis, the positive x-axis. If you're talking about this point's polar coordinates, you'll say, okay, fine, this is the distance from the origin, and this is the angle that it makes with the horizontal x-axis. Now, the question still remains active. Why do we even need to understand this? So the thing is, like what Dhanushi said, that it's used in case of radar. So basically, if you imagine this to be this is your polar plane, let's say, where any point that you're locating it along the circumference of a circle. So let's say if I talk about a polar coordinate of this point as r as the distance and the theta angle that it makes with this one, I'm still referring to the circle where the radius at every point on this circle will remain the same, but this is saying, okay, I'm only talking about this angle. which is made by against the x-axis. If on the same polar plane, if I'm talking about this point's polar coordinates, I'm talking about radius remaining the same, but my angle has changed. So without worrying too much about the first quadrant, second quadrant, third quadrant, fourth quadrant, you are able to locate a point against the origin and the angle that it makes with the horizontal axis. Now, if I'm talking about a coordinate plane, I will say be this point, okay, x and y. This point, let's say x1, y1. This point x2, y2. Let's say this point x3, y3. And we are able to locate them against the four coordinates and the x and y value against the x and y axis. Now imagine a situation, if I talk about, okay, this is theta. How about I rotate by two circles and come to this point. The normal coordinate plane doesn't give you that flexibility to go beyond 360 degree. But when you're looking at the polar coordinate, you're essentially talking about as many circles that you can make. I can say, okay, fine, I'll make 4 rounds, 2 round, 3 round, 4 round. That means 360 into 4, which is 4 6 24, 4 3 12 plus 2, 12 plus 2, 14. And then 30 degrees more. So I can talk about locating a point in this polar plane which makes 1470 degrees and has a radius of r. That flexibility of going beyond one iteration doesn't come in the offering when you talk about a normal coordinate plane. Wherein in the polar plane, you are essentially talking about revolving around a circle. That's one difference. Now you'll say, what is the application of that? So like Dhanush said, it's used in radar. Now think of a radar-like situation. Now we all know that there's a war going on between India and Pakistan, right? So let's say you have your searchlight that rotates at a certain angle, at a certain speed. Let's say it revolves at 60 degrees every 5 minutes. So a radar-like system doesn't really have to make one circle and stop. It will keep on searching for all infiltration in the Glenn interval. So there will be a lot of calculation that will be set up. There will be a lot of programming that will be done in the radar system. Say, to find it has to rotate at a certain speed, like I said, 60 degrees per 5 minutes or 2 minutes, whatever be the frequency. And then in last 5 hours, how many times it has rotated and what is the reading that it has kind of recorded, to know what is the speed at which, let's say, Pakistan army is attacking or some terrorist groups are kind of trying to enter into this. So there's a lot of calculation that can happen behind the scene, where just by knowing the coordinates, it will not help. So that was just one of the most lively example I could think of. But in simple terms, if I put it, coordinate planes just give you 4 quadrants, and all your calculation or location of a point gets limited to those 4 quadrants. Wherein when you are looking at a polar coordinate, you are talking about as many iterations you can do, and that gets fed into the systems for doing all the different calculations that once you guys opt a field of your choice, once you guys grow up, then you will see a lot of application of that. Okay. For now, we will just conclude that coordinate plane gives you only 360 degree view, wherein polar plane can give you million degrees if you want, yeah, in a given time frame. So where your certain operations are happening regular interval in a circular motion, this is where this polar plane concepts will help you, do a better job. Is that okay? I was not wanted to talk about the India-Pakistan war though, but ultimately there was one relevance that we could draw. Yeah, and if somebody is to be blamed, that is only Dhanusri because he gave me the reference of radar. I'm sorry, brother. I'm just kidding. Yeah, it is. So today we are talking about polar coordinates, and we just briefly touched upon what exactly is polar coordinates and what is the use of polar coordinates in real life. So in summary, if you're talking about a coordinate plane, it helps you locate a point against the four quadrants. When you're talking about a polar coordinate, this actually helps you make iteration against this circle as many times you want. So let's go into the calculation part of it. So, and whatever blabbering you missed, Dave, that we'll have to catch up by watching the video of the class. Okay, we have not missed much. So it's, in simple terms, what I was saying was a polar coordinate is something which is very much analogous to what we have learned in the vector. Okay, so when you talk about a vector, you say, okay, vector is nothing but it has a magnitude. The starting point is the ending point, and this is the direction. This is the direction. So polar coordinates also relate to the same stuff. So you will visualize the polar coordinates against the, let's say, the xy plane that we have. And if you're talking about this point, in the normal world, when we're talking about the Cartesian coordinates or the rectangular coordinates, we say what is the x and y value of this one. Wherein in case of polar coordinate, we'll say this is r and theta. Now, what is r? R is the distance from this point to the origin of the plane. This is the distance. And theta is the angle that it makes against the positive x-axis. So you can as well represent this is x comma y. This is your Cartesian coordinates and this is your polar coordinates. Now think of this like a circle. So basically this r is nothing but the radius of the circle that it makes against the origin. And theta is the angle. So we have picked up this point. So this is the theta. So this is represented in the polar coordinates like r, the radius of the circle that you are seeing here, and theta is the angle this line makes against the x-axis. Now if you are talking about, let's say this is 60 degrees. So the polar coordinate of this will be r 60 degree. If I am talking about this point on this in this polar plane and this one making 30 degree. So then the coordinates of this point would be r, so because this radius remains the same, and this will be 30 degree. This is the polar coordinate just with respect to how do we recognize this or locate this. Let's see if I'm talking about this point on this circumference. This point's polar coordinates will be r, and let's say this angle is 135 degree. So this will be 135 degree. So this is just to understand how do you locate a point in a coordinate plane, in a polar plane, not in a coordinate plane, which again is an extension of how you locate in the xy coordinates. Is this part okay so far? Dave, Chris and Dhanusri. Okay. Now let's look at what we want to know more about it. Now the second thing. Okay. So let's do a little bit of math before we move on. So let's say I'm talking about a polar plane. This is a polar plane, coordinate plane, whatever you call it for now. And this is my point. This is x-axis, this is y-axis. And I'm saying this is 5, 760. Okay, this is my polar. These are my polar coordinates. Meaning, 5 is the distance from this origin to this point, this straight distance, this length of this line, whatever you call it. Okay. And 60 is the angle that it makes with the positive x-axis. Now you will say, why we are complicating this thing? We are not complicating, we are actually relating this thing. Now with the same point, if I ask you, if my polar coordinates are 5 and 60 degree, what are the Cartesian coordinates or rectangular coordinates of this point? Meaning I am asking you what is x and y value. We can always find that, right? So x coordinate will be this distance, and y coordinate will be this distance. Let's look at it. This is 5, okay? This length is given 5. Let's say this value is y and this value is x. If you relate that to the basic geometry or the circle theorem, whatever we have learned, here I am saying this is a circle. What will be the case? But let's say this is point A, this is O, and when I am drawing a perpendicular from here to here, this is, let's say, B. So this OAB, triangle OAB that you see is nothing but a right angle triangle. And we can apply the basic principles of trigonometry to find out the value of x and y. So here, if this is theta, x by this is nothing but, x by 5 is nothing but cos 60 degree, isn't it? X by 5, I am again relating it back to the SOHCAHTOA, okay? X by 5 is nothing but cos 60 degree. Likewise, y by 5 is nothing but sine of 60 degree. And if you guys remember what is the value of cos 60 degree, it will be x by 5 will be equal to cos 60 is 1 by 2 and sine 60 is root 3 by 2. So from this you can find out x will be 5 by 2 and y will be 5 root 3 by 2. That is the value that you can derive. Is this part okay so far? Dhanushri, Chris? Okay. Now let's forget about this. Now I want to generalize this. I'll call this R, not call 5. I'll call this R, which is one of my polar coordinates, and the degree is, instead of 60, I'll say this is theta. So if you relate it, same SOHCAHTOA, x by R is equal to cos of theta, and y by R is sin theta. That means x equals r cos theta, y equals r sin theta. So what I am trying to say here is, if you know the polar coordinates, you can derive the Cartesian coordinates or rectangular coordinates as well. So if this is a polar coordinate, your x is nothing but r cos theta, y is nothing but r sin theta. And these two are relatable. You can always relate it and find it. So basically, now we have come to a point where we don't see a difference. It's pretty much the same thing. Same information with a different packaging or a different representation style. This one is called Cartesian coordinates, x and y value, and this one is called polar coordinates, where you have the radius and the theta. Is this part okay so far? If you guys don't say yes, I will get stuck here. Now there is one more unique thing that you will observe when we are talking about polar coordinates. So now look at this. This is, let's say, this point in the regular rectangular coordinate plane has value x comma y, and my polar coordinates are r and theta. So let me relate it this way. Let's keep x and y over here. That's fine. My polar coordinates are r and theta. Now, there is only one way to represent the x and y value in a coordinate plane, regular coordinate plane or rectangular coordinate plane. However, when you are looking at the polar coordinates, if you guys remember the concept that we learned in unit circle, every time you make 360 degree and come to this point, so or let's look at this way. Polar coordinate for the first revolution will be r cos theta, r sin theta. When I'm just talking about this theta. Now imagine I make one complete circle and then come to this theta. So at the same point I will have another polar coordinate where I can say r cos 2 pi plus theta, or I can 360 degree plus theta if that is easy to relate. R sin 360 degree plus theta. So same point I have two coordinates. Same point I have two polar coordinates, and I can keep on completing circles after circles, and I will have r cos 360 plus 360, 720 plus theta, r sin 720 plus theta. And I can keep on doing circles after circles, and every time I can keep on increasing by 360 degrees. So essentially, the difference between the polar coordinate and the normal Cartesian coordinates or rectangular coordinates is that there is only one value for a point in Cartesian coordinates, but it can have infinite number of value for the polar coordinate. I mean, the absolute value will be the same, but there are infinite ways in which you can write the polar coordinates of the same point. Basically, you are completing 360 degrees coming to that point. Again, 360 degrees more coming to that point. 360 degrees more coming to that point. Is it making sense? Yeah, Dhanushri?
Yes, sir.
Okay. Now, there is one more thing that we need to be aware of. I mean, there are many more things, but let's look at one more thing. So, if I say r theta as my polar coordinates, what I am talking about is this point is my origin, r distance, and theta angle. What if I say my polar coordinates are minus r comma theta? If I say minus r comma theta, that essentially means if I am talking about theta, so this is my line. R is in this direction, minus r will be opposite to that. So basically what it will be, whenever you flip your sign of the radius from positive to negative and keep the angle same, you are not measuring in this direction, you are talking about a point which is in the opposite direction with the same angle. So this is r, this is minus r. Let's say if I talk about second possibility, I say r but minus theta. Now you guys know that when we are measuring angle, we are always measuring in the anti-clockwise direction. Minus theta will go in this direction. So if this is this one theta, first thing you have to look at the angle, minus theta. So you have to go down by theta and then r in this direction. If I say minus r minus theta, this one you are going in this direction. So basically, whenever you are flipping the sign, you are kind of taking a mirror image of that in the opposite direction. Does it make sense?
Yes.
Okay, Chris, Dave. Okay. So what I will do is I will take a pause. I will let you guys just visualize it. If you guys have a notebook and pen with you, just try doing a scratch work. R minus theta, how will it look like? R plus theta, how will it look like? Minus R theta, how will it look like? Minus R minus theta, how will it look like? And basically you have to tell me which quadrant it's falling in. This is in which quadrant, this is in which quadrant, this is in which quadrant, this is in which quadrant. If you guys can do that exercise quickly, I mean just by visualizing it, doing some scratch work, that will at least help me get a confidence. While you guys are doing it, I'll quickly check what is the next topic. Are you guys able to play with it? Any doubt, let me know. Dave, Chris, Tanushi, are you guys able to wrap your head around this one? Is it okay for me to move?
Yes, sir.
Okay. So, this one, we are talking about which quadrant? Any guess? No, I mean, it's not a guesswork for sure. First one, we are talking about which quadrant?
Is it the second quadrant? Or
I will start with the angle first. So when I say theta, I'm going in clockwise direction, anti-clockwise direction. When I'm talking about minus theta, I'm going anti-clockwise. So I'm starting from here. This is my starting point, always positive x-axis, and then I'm going theta here. And R is positive. I'll just go by the direction of the angle. This is actually fourth quadrant.
oh, okay.
If I'm talking about R and theta, so again, theta is positive, so I'm going anti-clockwise, theta, R. Third one, minus R and theta. I'm still talking about theta in the anti-clockwise direction, but minus of that. I'm landing in third quadrant. Yeah?
So is the fourth one fourth quadrant?
So you'll always start with the angle. You'll always start with the angle. So minus theta. So you are going in this direction. If R was positive, I was talking about this. But I said R negative. So I'm actually flipping it. And I'm landing in it. So you have to keep your angle as your starting point because that tells you which way you are going.
I keep making like the negative horizontal instead of vertical. I keep that's where I keep messing up.
Right. No, so that's why I was see. It is more of a playful thing than anything else. Right? I mean, you guys would have kind of gotten Cartesian coordinates by heart now. We are just looking at the different representation. Don't go by the sign, okay? I mean, if I go by the sign, I will get. I mean, just looking at the signs of both the coordinates, I will probably get confused. I will always keep angle as my starting point because angle says which way I am going. Once I know which way I am going, then I look at the positive or negative of that. This is negative, going this way. I am actually from the against the x-axis, I am going this direction. I am landing here. Ideally, I would go this way. I have positive, I will continue this way. As soon as it is negative, but this one became negative, meaning instead of going this way, I failed. I went to land in second quadrant. And now you look at the signs also. Look at this one. Another way, okay, I'm just trying to relate, okay. I don't think I have a science behind this. Look at this one. In this quadrant, what happens? Your x and y, both the values are negative. No, don't relate it that way. Sorry, my bad. Ignore. Whatever I said, ignore that part. I was just trying to see by sign I can relate it to the quadrant thing. No, I cannot. This is a different representation. It will not work. I was thinking that this is landing in this quadrant. So if both are negative, x and y both are negative, then this relates to that, but that is not the case. So probably we'll skip that. Okay? So just know the angle. Positive is anti-clockwise, negative is clockwise, and then once you define the angle, look at the radius part. Does that make sense? Chris, Dave, everybody with me?
Yes, sir.
Now, so as I said, be it Cartesian coordinates or polar coordinates, they are essentially the same thing, just two different representations. Okay. So that means if I know the Cartesian coordinates, I should be able to derive the polar coordinates. If I know the polar coordinates, I should be able to derive the Cartesian coordinates. And let's see how it works. Let's say I know the Cartesian coordinates x, y of this point. I have to find out the polar coordinates. That if it is x, that means this distance is x, and y coordinate is y, that means this distance is y. What is the value of r? R and theta is what we are trying to find out, correct? What is r? This is Pythagorean theorem. This is right angle triangle. X squared plus y squared is equal to r squared, isn't it? Yep. So your radius would be nothing but square root of x squared plus y squared. Meaning, if you know the x and y coordinates of the Cartesian, if you know the Cartesian coordinates, squares, sum of the squares, square root would give you the radius, this distance. Now what is this angle? Now let's look at it. Let's try relating that in x and y terms. So this is y, this is x. So again, going back to Socrates, tan theta is equal to this divided by this. The side opposite to this angle divided by the adjacent side. So tan theta equals y by x. That means theta will be equal to tan inverse of y by x. So what we are seeing here is, if you know the Cartesian coordinates, then you can derive the polar coordinates. So my polar coordinates here, without me doing any calculation, I am saying radius is x squared plus y squared square root, and my angle is, which is theta, is inverse of tan of y by x. Yep. Is that okay?
Yes.
Okay. Now, so we knew the Cartesian coordinates, we could derive the polar coordinates. Now look at the other way around. If we know the polar coordinates, can I derive the Cartesian coordinates? Should be easy peasy. If I know the polar coordinate, that means I know this distance is r, and I know this is making angle theta with the x-axis, positive of x-axis. So this is the point. Let's assume this is x and y. Again, Socrates comes into play. We drop a perpendicular here, drop a perpendicular here, and look at this triangle alone. Let's say this is A, B, and this is O. So this here to here is y, here to here is x. Yeah, you know that what is known to you is r and the theta. And again, I am saying r and theta as variables. When you are dealing with a question, you will be given r equal to 10 or 5 or 9, whatever it is, and theta as 40 degree. That is what will help you visualize this one, and then you will derive that. But I am just trying to derive the generic formula, and then we will deal with it. Now, here, this is r that is known to us, and this is theta that is known to us. Now, what is the value of x? So, x by r is cos theta. which means x equal to r cos theta. Similarly, y by r is equal to sin theta. So y equal to r sin theta. So when you knew your polar coordinates, you could derive the Cartesian coordinates x and y. Yeah. So basically, what we have learned so far, we learned what is a polar coordinate, why do we need to know that, and I gave a very indecent example of India-Pakistan war, why it is used in a radar system, and then we also learned how do you represent the polar coordinate, what does the positive or negative of theta versus negative of the radius mean, and how do you represent that differently. And then we tried relating that with the Cartesian coordinates, and how do you convert from polar coordinate to Cartesian coordinate or vice versa. Yeah. So let's do one thing. I mean, I can just go on doing formula after formula after formula, but then math has zero value without practice. So let's do one quick conversion before we move on to. Let's say I'm talking about a question. I'm just making it up. Okay. I have a polar coordinate minus 13 and theta equal to, let's say, 60 degree. Okay. I want you guys to derive identify locate the point in the coordinate plane, derive the Cartesian coordinates for this point. Okay. And whatever you have learned, just draw it in a notebook and try solving it. I mean, you don't have to get me the accurate value of this one, but I want you guys to derive the Cartesian coordinates of this one. And the minimum that I would want you guys to do apart from deriving the x and y value is, make sure that you draw it and tell me which quadrant it is falling in. Yeah. And you will have 5 minutes for this. It's not a difficult one. Can I assume everybody is trying to give it a shot?
Yes, sir.
Okay. Easy peasy, difficult. And be honest, that's okay. You don't learn everything in one go. Sometimes it takes time, and that's okay. It's perfectly fine.
I think I got the point, but I don't think I did it correctly.
That's okay. What is that you got?
I got for the x, I got negative 13 over 2. And then for the y, I got negative 13 root 3 over 2.
Negative 13 root 3 over 2.
Mm-hmm.
Now you tell me why you think you did not get it right.
I don't know. It's my first time solving, so.
Okay. Promise me one thing. Be it right or wrong, never let yourself down, okay? You did right or wrong, that we'll figure out. But one thing I want you all to have is confidence. I'm not asking you guys to be overconfident, but it's okay. I mean, I kind of shake a little bit as a teacher whenever somebody says, I think this is the answer. No, I don't want any of my kids to say that. Sir, this is the answer I got. Now whether that is right or not, that we'll figure out. That's okay. But I want each one of you to be super confident, okay? That's a request. Okay. How about you, Dhanushri?
I'm almost done. Hold on.
Dave?
Sir, I got a little confused.
Okay. So that's why instead of rushing through the whole thing, right? I just wanted to do a quick, I call it acid test. That helps me understand whether or not I was clear with my explanation or not. It has nothing to do with you guys, okay? If there's something that you have not understood, that is because of the teacher. That's me. So I'll clear the rest. Don't worry. Dhanushri?
So I got like x equals negative 6.5. I mean that's the same thing as negative 13 over 2, I guess.
Mm-hmm.
And then negative 11.26, also the same thing as that.
Okay. So I'm trying to avoid getting lost in the calculation part of it. I'm probably stopping it there. So you both got the same answer. So let's see. Now the likelihood of you both being right is more, but let me see if I can add a little more weight to it. So Dave, you can probably focus on what I'm trying to do now. Okay, I'll do it like a baby would do. I mean, obviously babies would not talk about polar coordinates, but still. Okay, in a very simple form. That's what I'm trying to say. I'm talking about angle 60 degree. So 60 degree is always against the x-axis positive direction. Let's say this is 60 degree. But as soon as I saw this side, that made me believe that I have to go in the opposite direction. Along the same line, but in the opposite direction. Okay. So my funny sound. So I'm essentially talking about this point here. And the distance from here to here is 13. Yeah? I took out the negative part. I'm just saying this length, absolute length is 30. And this is angle 30 degree, 60 degree. Now, what I have to find is this y and this x. Yeah? Everybody with me so far? So as soon as you plot this, right, then life starts getting easier. Okay? Because our brain has some limitation. We can think, we can calculate, but visualization is better done on paper actually, or on the board, like what you are seeing right now. So now I know this is a triangle that I have. Let's forget about the sine part of it, okay? I'm saying this length is 13. This negative tells me that I have to go in this direction, but I'm looking at this 13 as a length, okay? And this is x, this is y. Now and this is my right angle triangle. So from this I know x by 13 is, if I look at this right angle triangle, x by 13 is nothing but cos of 60 degree. Yeah? Dave, you with me? Sukatra. Yeah?
Yes.
Now, that means x equals 13 into cos 60 degree. Cos 60 degree is nothing but 1 by 2. 13 into 1 by 2, which gives me 6.5 or 13 by 2, whichever you like. Okay. Now, what is y? Y is, again, I'm talking about absolute value, okay? I'm not looking at the sign part of it. I'm keeping myself away from this. I'm just trying to get the length, absolute length from here to here. Sine I will bother about a little later. Now what is the value of y? So y by this hypotenuse is my sine 60 degree. So y by 13 equal to sine 60 degree, or y equals 13 into sine 60 degree, or that means 13 into sine 60 degree root 3 by 2. Okay, so y value I got is 13 into root 3 by 2. X value I got as 13 by 2 or 6.5. Now, by looking at the quadrant itself, we know, okay, here the x is negative and y is also negative. Y is also negative. So I put a negative sign against that. So my Cartesian coordinates became minus 13 by 2 and minus 13 root 3 by 2. Whatever is the absolute value that you guys can calculate, that is okay, but this is what my Cartesian coordinates would be. So if you look at the step-by-step process, first thing and the foremost thing that I did was first locate which point we are talking about. Looked at the angle, drew it, then saw negative, that means I have to go in the opposite direction, and this is the point. So converted this to a right angle triangle to find x and y, and that is what my goals are. So x again SOHCAHTOA, y again SOHCAHTOA, gave me this value, absolute values, and then I realized, okay, x is along the negative of the x-axis, so whatever value I have got, I have put a negative to it. Y is also along the negative side of y, so whatever value I got, I have to put a negative to it. That's it. Dave, did I do a better job this time?
Yes, sir, I understand it now.
Okay. No, I don't have to be shy, okay? If I could not make you understand, that means I did not do a great job. This time I did better. Okay? Alright. So this is on the conversion from polar coordinates to Cartesian coordinates. Likewise, if you have to convert a Cartesian coordinate to polar coordinate, same thing will come into picture. If let's say somebody says 3 and let me pick up an easy one, 3 and minus 6. These are my, I'll do this quickly so that we can use last 5 minutes to learn something more, which will be a prelude for the next class. So let's say these are my Cartesian coordinates, 3 and minus 6. First thing first is, I will not rely on myself. I will try locating this point in this coordinate plane. 3 minus 6, meaning x is positive, y is negative. X is positive and y is negative. So we are talking about fourth quadrant basically. So let's say this is 3 minus 6. This is the point we are talking about. Now, I will join these two and drop a perpendicular in this point. So this distance is 3 and this distance is 6 in absolute value, okay? This is 6. Absolute value is 6. I'm talking about the length of this line, okay? I will ignore the sign for a little bit and I got this value. So here, let's say this is the theta. So I have to find out the polar coordinate. First thing first, Pythagorean theorem, 3 square plus 6 square will be equal to r square, or 9 plus 36, 45 equal to r square. R equals square root of 45. This is the radius I got. Square root 45. So r we got. Now we have to find out the theta. So theta is nothing but tan inverse of y by x. Y by x. 6 by 3. I got theta, this absolute value, okay? I got tan inverse 2. I don't know how much is that value. You can use calculator for finding it out. But let me say it is, I'm just making it up. Let's say 70 degrees, okay? And there is a reason why I'm saying approximately 70 degrees. Because tan 60 degree will be equal to sine 60 degree by cos 60 degree. That gives me root 3, which is 1.414, no, 1.732 or something. So I'm just increasing that by a little bit so that I'm going. So let's say from this I got theta equal to 70 degree. But this theta is actually going clockwise. So my polar coordinates, let's say this angle came as 70 degree as absolute, I can say this as 70 degree minus. As I am measuring this in the and the clockwise direction. If I want to measure this in the anti-clockwise direction, I will say 90 plus 90 180 plus 90 270 and plus 30 300. So I can say this as 300 degrees also. Now look at this. This theta was in this direction and we did not change the direction. We stayed with that same direction. So R is positive. So whatever is the value of R is called root 45. That remains positive. So look at this. For the same Cartesian coordinate, we got two ways to represent the polar coordinate. I could measure this clockwise and give a negative value. Is this 70? No, this is 270 plus 20, sorry, 290 degrees. That's why I was wondering how come these two are not adding up to 360. So the same polar coordinate, I could measure anti-clockwise and represent this way. I could measure clockwise and I could represent this way. Yeah. I mean, you don't have to necessarily find two values always. I'm saying, I mean, these are two different ways of looking at it. Yeah. So look at this. You have x and y coordinate as one being positive, one being negative, but that had no impact on r. R purely goes with the way you are measuring it. Okay? I mean, which way you are measuring the angle. If you are going opposite to that angle, that is when it becomes negative. But here we found the angle this way and measure in that direction. So that's why it stayed positive. Even if we went anti-clockwise, the angle stopped here and we measure in that direction of the angle. So it remained positive. Does it make sense or not? Everybody? Okay. Now, so you guys saw that, okay, how do we locate a polar coordinate? So in the polar coordinate you saw that, okay, there is something called r, which is the radius, and the angle that makes with the x-axis. These are the coordinates. Now, there is another thing that is derived out of it, and that's called polar equation, where they will say, okay, r equals, let's say 5 in the polar plane. If you are given this equation, r is 5, what is that we are talking about? R is nothing but a radius. You are essentially talking about a circle with a radius of r. And this is called a polar equation because it represents every point regardless of the angle on this circumference, which represents this equation, r equal to 5. Okay? So this is called polar equation. If I say r equal to 3 sine theta, I will plot it this way. If I say r equal to 2 cos theta, I will plot it this way. Now, cos, again, why I am doing all that without explaining anything to you guys? It's just to give you guys a jump start with respect to what we are going to learn in the next class. And that is, if I am talking about cos theta, if you look at the theta, this theta. When you're talking about cos, you're talking about the horizontal axis or x-axis. That's why when you're drawing a graph of a polar equation with I equal to 2 cos theta, this 2 is nothing but the length of the diameter, and cos theta says this is along the x-axis. If you say I equal to 3 sin theta, then you're talking about this diameter to be 3, and sin theta, again sin of theta is always in the vertical direction, so the circle is plotted here. Now why it is plotted this way, why it is plotted this way, we'll decode that in the next class and we'll go through that. I was just telling you guys that knowing the polar coordinates helps us locate a point. Now we are going from polar coordinates to polar equation and see how the polar equation helps us draw different types of graphs. We just looked at a glimpse of it and I got you guys confused, and I'm very happy about it because this is just a jump start. Okay, we'll talk about that in detail. Okay, I just gave you guys a prelude to what we're going to talk about in the next class. Okay, is that okay so far? Except the last 2 minutes of whatever mysterious thing I was talking about.
Yes, sir.
Manushri, Chris, everybody clear?
Yes, sir.
Okay. Then I'll let you guys go. Enjoy the rest of the evening. Have a good night dinner, good dinner and a good night's sleep. And see you guys on next Wednesday. And just information for you guys, if you have not noticed this Saturday the SAT class I'm skipping. The reason being I'm traveling out of station. But I'll be back on Sunday. So Sunday classes will be there. Saturday we will skip, and I'll do a makeup class for that in the coming week itself. So I have sent out the timing and the day for the makeup class as well. So even if Saturday we are not doing a class, use that time for spending time with family, and we'll catch up in the following week. Yeah, but Sunday classes will be there. All right.
Thank you, sir.
All right. Bye bye. Take care.
Right.
Thank you, sir.
Yeah. Bye bye.